The signs are troubling.
This is kind of different.
And they are everywhere.
We are flirting with climate disaster.
Melting glaciers, suffocating heat waves, more frequent wildfires, longer periods of drought, and extremely intense storms.
The question is, will it be part of our future? As the hots get a lot hotter, dries get a lot drier, and the wets get a lot wetter.
The expert consensus, Earth is growing warmer. Our weather patterns are shifting. Climate change is happening. And the main culprit is carbon dioxide, the invisible problem. Welcome, I'm Elizabeth Cook.
And I'm Ryan Yamamoto. So Liz, let's all just take a deep breath and exhale. Okay, we've just created carbon dioxide, or CO2, but not all carbon dioxide is bad. In fact, plants love it. They take in CO2, and along with water and sunlight, they produce oxygen and food that plants use to grow, but CO2 plays another important role. It acts like a blanket, trapping heat in our atmosphere that keeps our planet warm and makes life as we know it possible right here on Earth.
Well, the problem is when there's too much of a good thing. We're seeing extremely rapid buildup of carbon dioxide, way too much in the atmosphere. And the science is clear. These rising CO2 levels are a direct result of human activity, primarily the burning of fossil fuels. Humans are putting out far more carbon dioxide than the atmosphere than Mother Nature can even handle. And these increasing levels are changing the chemistry of our climate, and there are consequences.
And to help better understand what exactly is going on with climate change, CBS News Bay Area is proud to present a series of in-depth reports called On the Dot.
Joining us now is David Schechter, the national environmental correspondent for CBS stations and our On the Dot guide.
So David, you're going to take our viewers to places where scientists are measuring and documenting climate change, but this time you're speaking to us from your home base in Fort Worth, Texas. How you doing?
I'm good, Liz and Ryan. It's great to see you guys. Yeah, we're taking you to a lot of cool places, but sometimes it's nice to sleep in your own bed.
So David, why is your reporting called On the Dot?
That's a great question. You know, the whole idea is that really the planet is small. When you look at it from the vastness of space, it's just this tiny little dot. And we all live here, and we all have to share this place and use these resources wisely. So we wanted to kind of hearken to that vibe that we're all in this together, and that's the reason that we called it On the Dot.
All right, let's begin our trek. In the next half hour, you're going to bring us on 3 different journeys that look at the invisible problem of carbon dioxide. So where's our first stop?
Yeah, well, the first stop is a mountaintop in Hawaii. That's a very important place to go on our first stop. I enjoyed going there myself. And, you know, that is where they keep these very important records about this invisible problem.
We're going to the Mauna Loa Observatory, and this is where the carbon dioxide readings come from. And I'm like, I gotta go see that place.
When it comes to office views,
Thanks for having us out, man.
Yeah, of course.
Aiden Colton is crushing it. We visited him before a recent volcanic eruption temporarily interrupted operations up here.
It's not the easiest place to get to, as you can see.
No, it wasn't that easy.
It's not the easiest place to work. It's 11,000 foot elevation. You know, every time you take a breath of air, you're breathing in a third less oxygen.
Too much carbon dioxide in the atmosphere is what drives climate change. And for the last 65 years, scientists around the world have relied on the carbon dioxide measurements taken on Mauna Loa. Aiden is the guy who takes them, and he invited us to come along.
This is the Carbon Cycle NOAA portable sampling unit. And what we're doing here...
Kind of looks like the nuclear launch codes might also be in there.
Yeah. Luckily, they're not.
Aiden's telling me the air up here is what makes this remote location so important. We're more than 11,000 feet up, far above any ground level pollution from communities below, and we're surrounded by 2,000 miles of ocean. So by the time air makes its way here, it's been blended with air from across the globe.
All right, so we'll just hold our breath, just because that's what I usually do when we get like 10 seconds. But once I close it off,
We have to hold our breath?
it's very hard to affect it, but we don't want to contaminate.
Tell me when I have to hold my breath.
I looked over at you and I'm like, I don't think you're gonna be able to do this.
Chance. Hold your breath.
I couldn't hold it. I had to breathe.
These samples, gathered once a week, will be sent to a lab for analysis. There's also a tower, another 140 feet up, that pulls and analyzes samples 24 hours a day, determining how much carbon dioxide is in the air at such a high altitude. You have all this research from this location. What story does it tell?
Our job is to present the facts. And the fact is that carbon dioxide is increasing, and it has been increasing since we started monitoring it.
Starting in 1958, this graph of samples taken in Hawaii shows the concentration of carbon dioxide in the atmosphere rising year after year after year. Now let's go back in time by 800,000 years. By studying things like ice core samples, ocean sediment, and tree rings, scientists have a good idea how much carbon has historically been in the Earth's atmosphere. It goes up and down over time, but it's never crossed this line. And now, let's bring things back to what's happened in the last 65 years.
The CO2 in the atmosphere has never been seen this high in human history. It's harder and harder for me to speak to people like yourself and be optimistic. I want to see some change, and I want to see it start to plateau.
David, that was remarkable. It's really hard to fathom how quickly CO2 levels have risen.
It is. That's what I wanted all of us to go and see that together, because it's such a critical scientific achievement that's up there. But you kind of need to get a little bit of baseline to understand that number, it never goes down. And that really is the root of our problems.
And you say the air that's measured in Mauna Loa is blended. So what does it exactly contain?
So you get this air from all over the world. Of course, they're measuring carbon dioxide. They also measure things like methane. They're looking at the ozone. There are many, many measurements that are happening on top of Mauna Loa, so we don't have to worry about it. But they're basically like the police of the atmosphere. They need to know what's up there, and it's a lot of things. And they need to make sure, like carbon dioxide, we know what is happening.
David, recently NOAA had to scramble to find a backup spot to measure CO2 in the atmosphere. Why is that?
So, a great question. Right after we were there, the volcano erupted on Mauna Loa. The lava came down and covered up the road that you saw us traveling, and so the scientists couldn't get in and out. And so they had to move some of this equipment to a nearby volcano. There's kind of a break in the data, which is significant considering this kind of goes all the way back to 1957. But assured that the record keeping is still pristine, immaculate, despite this small gap that happened up there. And there are other ways around the world, not just Mauna Loa, that they are recording these levels of CO2 in the atmosphere.
Amazing what they were able to find up there, though. Remarkable.
All right, well, thank you, David. We'll check back with you in just a minute. In the meantime, coming up, the Bay Area company that's putting CO2 on the map, block by block.
How a candle, a camera, and a piece of glass can put climate change all into focus. We're here with On the Dot correspondent David Schechter.
And David has done an in-depth series of reports on carbon dioxide, the root cause of climate change. So tell us, where are you taking us now?
We're going to be in your backyard in the Bay Area. We're going to go for a ride in this very specialized car that helps you see carbon dioxide with your own eyes.
So we've got a lot of carbon dioxide. Now let's talk about where it's coming from.
So I think this next stop would be pretty cool. This company has figured out how to visualize carbon dioxide.
Hello.
Davida Herzl is the CEO of Acclima. In Oakland, her company operates a fleet of cars outfitted with tubes and sensors that analyze the air for 14 kinds of pollution. One of them is carbon dioxide, which floats straight up into the atmosphere and can stay there for hundreds of years.
To deal with climate change, to deal with air pollution, you really have to understand where it's coming from, and you have to take local measurements to do that.
As we're driving, how many measurements are happening right now?
Right now, every single second, we're taking a measurement.
Off this hose?
Off of that, yeah, the air is getting sampled. We're moving through the streets. That enables us to pinpoint the precise location of those measurements.
There are a lot of ways that carbon dioxide gets into the air, but according to the EPA, the number one source of carbon emissions is transportation, at 27%.
You can look out the window. I can count 1, 2, 3, 4, 5, 6, 7. 10 trucks just in front of us right now.
Diesel trucks.
Diesel trucks. And what you're looking at here, that's the CO2 coming off of these trucks.
What she's showing me is a visualization of carbon dioxide on the streets of Oakland. The lower concentrations are purple on the side streets. The much higher yellow levels are freeways. And those things that look like skyscrapers are emissions where two highways come together. Businesses and governments use Acclima's data to identify and reduce sources of pollution.
This isn't just an invisible problem. You can now see it. It's visible. It's measurable.
And when I drive,
And when you drive,
contribute.
you're contributing. You're putting CO2 into the air.
Yeah, we call this the invisible problem, but when you have that graphic up and you can actually see it with your physical eyes, it makes a complete difference about how you think about carbon dioxide.
Yeah, especially in our own backyards, too. It's easy to think, oh, this is happening someplace else. And no, this is happening on our freeways here in the Bay Area.
And David, so most CO2 levels, they're found along the freeways. So that brings up the question of who exactly lives there?
This is a question of environmental justice for sure. These are low-income, high-minority communities that are in these corridors. They're there. The carbon dioxide is less of a concern to their own health. It kind of goes up into the atmosphere. But there's so many other things also in that air that are heavy pollutants and have a disparate impact on the people that live near those highways.
Yeah. All right, David, thank you so much. Well, experts believe climate change will actually intensify some of the health threats and create brand new ones. We may see increased respiratory and cardiovascular diseases. In addition, higher pollen counts and longer pollen seasons could also happen. And that could lead to a jump in asthma attacks, and more people can land in the hospital. Extreme rainfall and warmer temperatures could lead to things you might not expect. A dangerous increase of mold growing in your home. We may also see more mosquitoes, ticks, and fleas carrying potentially dangerous pathogens. Coming up, David swings by a science center. He shows us how a simple candle, a special camera, and a piece of glass can illustrate climate change.
Well, welcome back to On the Dot, Carbon Dioxide, the invisible problem.
CO2 may be invisible, but the results from too much of it are not. Just look at all the damage from the intense storms that recently pummeled California. Scientists are scouring the data, but it's likely this extreme weather was due to climate change. The swamped roads, battered coastlines, downed trees, and damaged homes could cost the state more than $1 billion.
And we've seen with the recent storms, the impacts of climate change and rising CO2 levels can really impact our environment and our weather patterns. Part of the discussion needs to involve what's known as the greenhouse effect. We mentioned it earlier. That's when carbon dioxide actually traps heat. But David, you're going to show us one of our favorite places, the Chabot Space and Science Center.
Yeah, it was my first time there. What a cool place. And when it comes to talking about carbon dioxide and explaining it, the guy we met there, no one holds a candle to this guy.
So the level of carbon dioxide in the atmosphere has exploded, and transportation is a major contributor. But why is carbon dioxide a problem?
We're trying to get an idea of how this greenhouse effect works. How does CO2 have this power over controlling the Earth's temperature?
Dr. Eugene Cordero is a climatologist at San Jose State. We're meeting up at a science museum in Oakland, and he's going to help us understand the greenhouse effect, where carbon dioxide functions like a blanket around the Earth. He's telling me as the Earth naturally radiates heat, the carbon dioxide in the atmosphere retains some of that heat, and that's what makes the planet comfortable. His demonstration here involves a candle, a camera, and a piece of glass.
So you were kind enough to bring a candle. I also stopped and got a few candles.
Oh, cool.
Fresh lavender breeze.
Oh, that's
That one
nice.
smells pretty good.
Yeah, so we're going to have a heat source. This represents the Earth. So the Earth gets warmed during the day by the sun, and then it gives off energy. So we have
This is the heat of the Earth?
Yeah, right there.
Okay.
So we have our planet right there.
Okay.
And then we have this camera, this special camera that senses infrared radiation or heat. And that's like a satellite orbiting the planet. To be honest, that's the best way to measure this greenhouse effect.
From space?
From space.
Is this our carbon dioxide?
Yeah, it behaves in the same way because it absorbs this particular type of radiation.
So I'm going to basically put the carbon dioxide.
You're going to put this blanket of carbon dioxide
in between the Earth and the satellite in space.
Yeah.
It just disappears.
Take a closer look at the candle. The wavelengths of heat show up as white, red, and yellow. When the glass comes into frame, it shows up as solidly purple, so you can't even see the candle behind it. Dr. Cordero is saying when you add more carbon dioxide to the blanket around the Earth, our planet retains more heat.
Our natural light from the sun passes through, but then the infrared radiation on its way out
can't get out.
Can't get out. But now we have a lot more CO2 than we used to, and so our planet's temperature is going to go up. It's a great thermostat.
Now let's take another look at that graph from Hawaii. This is the line that shows carbon in the atmosphere going up and up. Now add in global average temperatures. As the carbon dioxide rises, the temperature rises too. Dr. Cordero says a large body of research shows us that is what's driving extreme events like fires, floods, and drought.
How long have we known that carbon dioxide can do something like this?
Yeah, over 100 years.
Over 100 years.
Yeah, so that the CO2 and other greenhouse gases is the largest contribution to changing what our planet's like right now and making it warmer. There's other factors too, but carbon dioxide is the number one.
How worried should I be about that piece of glass?
I think this is our main social environmental challenge for humanity.
When it comes to climate change, carbon dioxide is an invisible problem. But we've seen, with a little imagination, it's not impossible to understand what it's doing up there, where it comes from, and how we have more and more in the atmosphere every year. Together, we're going to explore how changing the climate changes our world.
So, David, you covered three very important stories about three different ways that carbon dioxide impacts our lives. I mean, what was your biggest takeaway from doing these stories?
I mean, I guess for the most part, that it's not that complicated. You know, there is a lot of science there, and the science is very specialized, but the idea of we make it, it goes up there, it stays there for a long time. And maybe a lot of people know that, but like to see it and feel it and kind of understand that a little bit better, I hope people can walk away and talk about this with their friends or their family and say, I kind of get it. It's not that complicated. I kind of get it.
Yeah, I thought that example with the candle and the piece of glass is like representing the blanket of CO2 around the Earth. I thought that was really visual and you really understood the impact of this heavy blanket of CO2 and what that's having in our environment.
Yeah, I think that that demonstration, again, really simple, but impactful to realize that when you put a blanket on when you're in bed and then you put another one on, you're just going to keep getting warmer. And that's basically what we're doing.
That's what's happening to the Earth.
What do you hope people get out of this? I mean, the one thing that strikes me is you were able to visualize a lot what we're calling the invisible problem. But now that you can be able to see it and other people can see it, how do you hope people react to this?
So I would like all of us to, first of all, really understand this, realize it's a very complicated problem. We're not going to be bringing you silver bullet solutions. There's a lot of silver BBs out there. We want to talk about solutions. The thing that we saw in Oakland, that's a small solution or a way to adapt, figure out what's going on, hold people accountable for what their emissions are. We're going to go through a lot of things together. We're going to talk more about the problem, but talk about the solutions. And hopefully we can get to a place where we can be moving in a better direction because as we know, the world that we leave to our kids is sort of in jeopardy right now.
Right. It'll be interesting to see how our choices are really going to change in the next few years.
Absolutely.
Thanks to reporting like this, no question.
All right, thanks, David. We'll join you in just a bit once again, but still ahead from us, a list of the biggest emitters of carbon dioxide and how this, black dress may actually help.
Welcome back to On the Dot, Carbon Dioxide, the invisible problem.
Okay, let's shed a little light on which nations emit the most CO2. With the world's largest population, one of the fastest growing economies, China is at the top of the list. In second place, the United States. India comes in third, then the Russian Federation, followed by Japan. And there are steps the world can take to remove excess carbon dioxide. The main solution is the most obvious one: cut emissions. But that will take a concerted effort by all countries.
Yeah, countries can remove CO2 by planting more forests, restoring old ones, even coming up with ways to suck it out of the atmosphere and then trap it into the soil or even the ocean. Then there's this. How about a microbe brewery that will turn you into a fashion icon? To halt global warming could cost up to $50 trillion over the next 20 years. In the meantime, how about this little black dress? It's actually made from carbon emissions.
We convert pollution into the products you use every day.
LanzaTech is a carbon recycling company. It turns carbon pollution into everything from those party dresses to plastic bottles, Lululemon gym shorts, household cleaning products, and even jet fuel that powered a recent Virgin Atlantic flight from Orlando to London.
We've done it at commercial scale, and there are real products out there, so it's real.
The company currently has 3 facilities attached to steel plants in China that capture carbon emissions before they're released into the atmosphere and converts them into ethanol, the building block of countless products. Key to their strategy? Carbon-eating microbes.
But those are microbes eating carbon dioxide?
That's right. So actually, the reason you see all the bubbling is because the carbon dioxide is being bubbled through the reactor.
The technology can also be used to make products from carbon found in landfills, which could make things that we now throw away infinitely recyclable.
We believe in a future where there is no such thing as pollution or waste. That is always going to be your next raw material.
Each facility costs about $100 million and can take years to build. But LanzaTech hopes the technology could eventually cut global carbon emissions by 10% and help clean up often toxic air in countries such as China and India. As for that little black dress, it's a steal at just under $70. And it's cute, too. All right, we're joined again by our On the Dot guide, David Schechter. Your series was remarkable, so eye-opening. What else can we expect with On the Dot?
We have a lot of really interesting reports coming up. The intersection between climate change and extreme fire, looking at sea level rise and how communities adapt to sea level rise. Those are 2 pretty California-centric stories. We're also looking at winter and how winter is getting warmer. Some people might like that because it feels like it's a little bit better, but actually a lot of negative implications of a warming winter that we're having.
All right, looking forward to your reporting, no question.
Yeah, thanks, David, for all your marvelous reporting. Look forward to your next installment. And I think both of us agree that the dress looks better on Liz.
Oh, we could try it out. You never know.
Well, you never know.
They're going to make us
we don't judge.
All right, thank you so much for joining us as well. See you next time.